Hello, welcome to my presentation. Since there are plenty of reports recently saying that this orderly Brexit will be worse than financial crisis, and the macroeconomic environment of the UK shows a downward trend. So today my topic is going to focus on under the condition of Brexit, whether the investors will withdraw their funds in financial institutions in UK or European. Here is a real-world situation which inspires me to the game. Policy changes due to Brexit. If the macroeconomic development shows a downward trend, investors cannot ignore the value changes of their assets in financial institutions. Due to the psychological association of investors, they may withdraw their funds. Then, how to describe this in my game? And how to describe the intermediate state that some people keep storing their funds while others withdraw their funds in advance under the condition of Brexit. Here I set some basic backgrounds and key assumptions. Identical investors store one unit fund in the same financial institution in period zero. The financial institution promises to the investors who don't withdraw his fund until period one will be paid more. Otherwise, the investors can only have his principal back. Let R denotes the real interest rate. The whole yellow part proves that the investors who don't take their fund until the due date will get a lower rate of return, which is lower R in this case, if there are one investors withdraw their funds before the due date. The following part is a key assumption of this game. Assumption 1. There is error between the value of R that the investors predict and the real value of R. Assumption 2 is about the incomplete information. Investor I can observe RI but doesn't know the RJ that other investors observe, and the investor I doesn't know whether the other investors decide to withdraw the fund or not. So RI is a type of investor I. Assumption 3 is about regional investors. They want to maximize their utility. So I denote L equals to N1 over N, and I give an equation of expected value of L. P denotes the probability of an investor withdrawing his fund. F is a strictly increasing function of L. So for investor I, there is equation 2. Moreover, when investor I observes RI, he predicts RI and PI. Plus, in the investors are risk neutral, so I take expected rate of return as the indicator. Then equation 2 can be rewritten as equation 4. After some calculation, here comes to the most important part of the game, which is equation 6. It means the posterior estimate of I is pi. Then then we can get the posterior distribution of R. Moreover, the investor I knows his own types and predicts the other investors' types, which makes up the base game. So at this point, I can get the results if the value of R is small enough, or PI that the investor I observes is small enough. Withdrawing his fund is the advantage strategy, no matter what other investors are going to do. I constructed this game in two ways. One is to describe from the perspective of the supermom of PI. I got the result from this perspective of supermom is that when the dominated strategy is withdrawing his fund, when the investor I observes PI is smaller than P. Similarity, when RI is large enough, then the dominated strategy is not withdrawing his fund. From the perspective of infamum, I got the result that the strictly dominated strategy is withdrawing the fund if the investor I observes PI is larger than P. Finally, it comes to the game solution. When the equation written in yellow has a unique solution P star, if PI is smaller or equal to P star, the investor I will withdraw his fund in advance. Otherwise, he will keep his fund stored. This is the Bayes-Nash equilibrium, since Pi is a random variable with positive variance. In general, there are plenty of people choosing to withdraw their funds in advance or just keep their funds stored until maturity. This describes a general situation. What lessons I learned from this solution? This Bayesian game can explain intermediate states that some people keep storing their fund while others withdraw the money in advance under the condition of Brexit. If the observation error is not sufficiently small and the macroeconomic situation is getting worse, public expectation of the return on investment will be downward, then they will withdraw their funds in advance. The probability that financial crisis happens instead. When the observation error is sufficiently small and the macroeconomic situation is getting better, the situation is exactly the opposite. So that's all my presentation. Thank you for your time.